I wish to discuss whether the Jarrah forest, Eucalyptus marginata, is under threat from climate change. And to do that, I'll look at changes in hydrology, in vegetation and in biodiversity between the years 1972 to 2024. My name is Frank Batini. I'm a professional forester, and here I am in the Jarrah forest with a regrowth tree which is approximately 140 years old and 100 centimetres in diameter. I acknowledge that I have collated data from many authors into one report. Because the data was scattered and only some were published, there was a high chance that some data could be lost. And I've also updated field data from 2012 to 2024, when most of the research was completed in 2012. This slide shows the state of Western Australia, which is about a third the size of Australia. The forest is about 2 million hectares, and it's located in the extreme southwest of the state. The other larger slide shows the cleared agricultural areas on the east, the forest in red, and the town or the city of Perth, the capital, where about 85% of the population of the state lives, and then the Indian Ocean to the west. So you can see that the forest is juxtaposed very, very closely to the main centre of population. An example on the left of the old growth forest, high biomass, over 600 cubic metres per hectare, 30 metres in height, growth rates relatively low, and on the right hand side another photo of the 140-year-old regrowth forest. In this case, this forest has been thinned on 2 occasions, providing saw logs and other forest products. We are nominally in a Mediterranean type climate, and there's a risk of bushfire every year with quite extreme consequences for catchment values and biodiversity values. And to reduce the risk, there's a very large program of prescribed burning which takes place either from the air or from the ground. The aim of the program is to burn about 200,000 hectares a year, and to keep about 45% of the forest in a state where the fuels are less than 6 years old, and so are able to be managed and controlled safely in a wildfire event. The forest, of course, has several values under broad headings of environmental, social and productive. We've got biodiversity and catchment protection, recreation and tourism, the production of water, of timber, of honey and of minerals. We will now talk specifically about the 31-mile brook catchment, which is about 50 kilometres southeast of Perth and feeds into Canning Dam. Nominally, the catchment is in the higher rainfall belt, which we express as over 1100 millimetres per annum. It is 2,000 hectares in size, and it's been harvested for timber 3 times before 1950 and hasn't been harvested since. The soil is very ancient and fertile, with lateritic soil on the surface above deep clays. Other catchments are mined for bauxite by Alcoa, and here is an example of a site post-mining. Looking at hydrology, since 1975 the rainfall has fallen by 15%, but streamflow has reduced by 80% because of a major reduction in the wetted area. Flow days have fallen by 50%, and in 2010, which was a drought year, streamflow was only 3% of the pre-1975 values. In the 10 years 1992 to 2011, the water tables fell 6 metres, and the loss of soil water over 25 years has been estimated as 1100 millimetres. The contribution to this has been estimated as rainfall 60% and vegetation 40%. This is due to the fact that the water use by smaller trees is about twice that of large trees. There is no difference between small and large trees in the ability to move water through the system, but the small trees have a much larger cambial area in relation to basal area, and they also have larger crown cover or leaf area. However, we need to remember, however, that these changes in hydrology have been compared to a baseline of 1911 to 1974, which were unusually wet years. The response of the forest has been unusual. From 1989 to 2007, as rainfall and stream flow were decreasing, the forest canopy actually increased. From 2007 to 2009, the canopy increased by 70% to a leaf area of 1.5, that is 1.5 square metres of leaf area per square metre of ground. After 2010, drought year, the canopy fell by 27%. And so it just shows that the canopy in this forest can adjust very rapidly to prevailing conditions by shedding leaves and even large branchlets. Looking at the catchment water balance from 2004 to 2010, the mean annual rainfall 947 and the mean annual water use of 948. Overstory and understory and bare ground approximately the same, and interception 121 millimetres. During this time, soil moisture decreased by 63 millimetres per annum and the water tables fell. The runoff was 61 millimetres, or about 6% of the rainfall, coming out of storage. You would expect that such large changes in hydrology would have major effects on environmental values. The 2010 drought led to extensive crown scorch and some deaths, mainly on shallow soils near rock or 2% of the catchment was affected, and Jarrah was more susceptible than Marri. 60% of the stems in affected area eventually recovered through epicormic shoots. These are shoots which are protected under the bark. Looking at aquatic biodiversity, we have data which span 27 years, from 84 to 2010. And we noted changes in abundance, particularly for species that have longer life cycles, as you'd expect, as the time that the stream flowed was reduced significantly. These include some species of conservation significance, and the breeding habitat for frogs, native fish and mussels was also reduced. Looking at vegetation, we were fortunate to have an excellent baseline set up in 1972, 500 plots, each 40 metres by 40 metres in the 2,000 hectares. And on these plots all trees were measured and understory species were recorded on subplots, 8,000 subplots in total. From these data, a vegetation map was prepared. In 2012, we were able to remeasure 480 of those plots and prepared a second vegetation map which was very similar to the original. Comparing 72 and 2012, we noted that some species which prefer moister soil were less abundant, and that's reasonable as there was much less moisture in the soil. We noted some tree deaths near rock surfaces, as I mentioned earlier, but there was no major collapse of streamside or other vegetation. I conducted road surveys in 2020 and in 2024, and these show that the forest is still very healthy. Looking at terrestrial biodiversity, most terrestrial species and many of the birds rely on dense streamside vegetation for cover, for food, and so as to avoid predation. This vegetation is very healthy, as you can see in the larger photo, showing primarily the dense understory and also the white-barked eucalyptus tree, Eucalyptus megacarpa or bullich. The mainland quokka is still surviving in this dense vegetation, and so the impacts to date on terrestrial biodiversity are quite minor. We carried out some simulations modelling using 25 years of data, and the model was used to make predictions on water tables, on stream flow and on thinning. You can see in the two diagrams on the right the very large change in wetted area between 1974 and 2008, and it is this wetted area which generates a lot of the stream flow. Looking at thinning as an option to reduce the pressure on the environment, we noted that thinning to a basal area of 14 square metres per hectare would improve stream flow, would increase flow days, would raise soil storage, and would stabilise water tables to 2010 levels. If no thinning were carried out, the stream flow, the flow days and the soil storage would all decrease. Conclusions. I believe this is a valuable long-term study. There are not many studies that span over 50 years of data. And although we've had major changes in rainfall and hydrology, we've noted only minor changes to vegetation and biodiversity. And the ecosystem has shown a great deal of resilience. Tree studies to 1350 Common Era show that the forest has survived drought many times before, and this is no doubt the reason why it is showing resilience now. The forest structure has of course changed due to timber harvesting, and this has increased water use through changing of the structure from fewer larger trees to more smaller trees with greater canopy. And we've also noted that mitigation by thinning and also by prescribed fire would be possible, with prescribed fire reducing the transpiration of the understory, but possibly increasing evaporation from bare ground. I would note that a bushfire burning over 3 to 4 days would do far more damage to the biodiversity of the Jarrah forest than 53 years of climate change have done. And here is an example. This is a Woolwich wetland devastated by the Jarrah bushfire. Trees, understory and fauna species have been killed over thousands of hectares. Habitat has been destroyed for years. Thank you.